if you have the same bases and they're both raised to an exponent, that if I wanted to solve that, I don't really need the bases anymore, right? If the bases are the same, and I tell you there's an equal sign here, doesn't that mean that their exponents would have to be the same? Okay, that's all I'm saying. So when we're solving then today, our goal is to get the same base on both sides. Okay. And what I will tell you is sometimes there's more than one way to do that. Like I would say in most cases I'm going to just rewrite one of the bases in terms of the other, but some students will sometimes say, well, couldn't I rewrite both of the bases? And that's true. So here's kind of where I'm at with this. This does require a knowledge of exponents, and so those of us who are not really good with our cubes and things like that are going to struggle, and you're going to need a calculator to check, okay? You're going to take a look at these bases. This is a 2 and this is an 8. Are they the same? No. And so what we're going to do is we're going to try to take, usually it's the larger number, which is the 8, and we're going to try to rewrite that as the base of the other side. So what's the base of the other side? 2. So I'm going to try to take this 8 and I'm going to try to write it as 2 to some power. 2 to what power is 8? 2 to the, not 2 to the 4th, that's 16. 2 to the 3rd, and this is where you have to check, okay? Or some of you remember I had those roots from the other day, you could have that out as well. So I rewrite that 8 as 2 to the 3rd. All I just did is rewrite the 8. We agree that 8 is 2 to the 3rd, that's the same thing, right? What's still there is that other 3. All right. Now on the other side, that was already written as a 2, so I'm going to leave it the same. So once I have those things the same, if possible, I'm going to simplify the exponents. Do you see how I have 2 exponents here, a power to a power? Do you remember what I do with those? Cancel? Not cancel. If there were 3 and 1/3, I would. What can I do with these 2? This is like 2 to what power? 2 to the 6th. Okay, power to power rule is you multiply them and then I solve the resulting equation. So now I'm going to set the exponents equal to each other. The exponent over here is x. The exponent over here is 6. It would be x to the 6. Now go, if you want on your calculator, go ahead and check. Does 2 to the 6 equal 8 to the 3rd? All right, so that's the concept here. Example 2. All right, so I want to take the higher base. What's the higher base? 9. I'm going to rewrite it as the other side. 9 is what? Write it as an exponent of 3. 3 to the 2nd. But what exponent is still out there? 2x minus 1. Okay, are the core bases the same? Yes. So now what we're going to do is we're going to multiply these exponents together. So I have 2 times 2x minus 1 equals 6x. Notice I'm multiplying the 2 by the whole thing, 2x minus 1. Don't forget that step. All right, now we're going to solve. What should we do? We're going to distribute. So this is 4x minus 2 equals 6x. Move the 4x to the other side. We have negative 2 equals 2x. Divide by 2, I'm getting that x equals negative 1. Okay. Now, these are a little more challenging. So what about if I have something with a fraction? Well, you got to remember something about how to get the fraction to flip around. What do we do to make a fraction flip around? Well, the reciprocal means what kind of exponent is what I'm saying. So reminder that x to the negative m power is the same thing as 1 over x to the m. And the opposite would also be true. If I had 1 over x and I raised it to the negative m power, I would flip that around. And that would be the same as x to the m. Okay. So on this one, I'm actually going to rewrite both sides. This one, there's several ways to do it. As exponents of 3. How could I tell it was a 3? Because this is a 1/3. Okay. So 1 over 3 is the same thing as 3 to the negative 1 power. That should be a negative 1, should be small. I don't know why I made it so big, but now it's done because it's in pen. All right, we still have a 5x minus 6 there. All right, if you need calculators, get your calculators out. 3 to what power gives me 81? Let's see, 3 squared is 9. 3 to the third is 27. 3 to the fourth is 81. So this side I'm going to write as 3 to the fourth, and then negative x plus 3. All right, do they both have the same basis? Yes, they do now. So now I multiply my exponents. I have 4 times parentheses negative x plus 3 equals negative 1 times parentheses 5x minus 6. And away we go. So that leaves me with negative 4x plus 12 is equal to negative 5x plus 6. What do I do now? Are we adding 5x to both sides? So I have x plus 12 equals 6 now. Right? Is it negative 4x plus 5x x plus 12 equals 6? Are we following? Okay. And then I just would subtract that 12. So x would equal negative 6. Okay. What are your questions about that? How are we feeling about 1 and 2? You can just give me an indicator. How are you feeling? Examples 1 and 2 were very similar to each other. Are we feeling okay about that kind? Okay. How are we feeling about 3? Okay. Yeah. Sure.
With number 1, you multiply the exponents, right? 3 times 3 is 9.
Oh my gosh. Yes. Are you Jolly Ranchering me, Logan? 3 times 3 is 9. Yikes. Yeah, and you wait, let me get all the way to example 3 before you said something. You meanies. All right. I think because we're going to go through tests and stuff, I'm going to stop there today. And then